Have you ever really stopped to wonder why a lemon is so sour, but something like baking soda is bitter? It's not just random, you know? There's a secret chemical language happening all around us, in our food, in our bodies, everywhere, and today we're gonna crack the code.
Yeah, that simple question. It's the key that unlocks a whole world of chemistry. We're talking about a daily clash of titans, right? A battle between acids and bases that's going down in your kitchen, probably as we speak.
And the key to understanding this whole thing, it's right here. This beautiful, colorful spectrum, the pH scale. Think of it as our map to that hidden world. It looks simple, but wow, it organizes pretty much every liquid you can think of.
Okay, so what's it actually doing? Well, the easiest way to think about it is like a ruler for chemistry. It's this simple scale from 0 to 14, and all it's really measuring is how many hydrogen ions are floating around in a substance. The more of those ions you've got, the more acidic something is. Simple as that.
And here's the big rule of thumb. 7 is neutral, like pure water. Anything below 7, that's your acid. And yep, that's what gives you that sour pucker. Anything above 7 is a base, or an alkali. That's where you get that bitter, kind of soapy taste. They're like perfect opposites, you see. One side is all about releasing hydrogen ions, the other is all about releasing hydroxide ion.
But look, this isn't just some boring concept from a chem lab. No way. The pH scale is a fundamental code that's literally essential for life itself. Let's dive into just how much it shapes our world.
Take this number, 5.5. It looks totally random, right? But it is absolutely critical. This is the exact pH level where your tooth enamel, you know, the hardest stuff in your entire body, starts to dissolve. That's right, this is the tipping point for tooth decay.
And this delicate pH balance is just everywhere you look. Think about it. Your stomach needs a super low pH, a really strong acid, just to digest your lunch. The environment is incredibly sensitive to it. Acid rain can drop the pH of a river and threaten all the fish in it. Even the plants in your garden won't grow if the soil's pH is off. It's that important.
And what's really fascinating is that nature figured this out a long time ago. I mean, we're talking about millions of years of chemical warfare, a constant, epic battle of acids and bases playing out all over the natural world.
You know this one, right? A bee stings you, it's injecting acid into your skin. And what do people say to put on it? A paste of baking soda, a mild base. It neutralizes the acid. Or how about this? A stinging nettle gets you. It uses its own acid. And the old folk remedy? Rub it with a dock plant leaf, which is a base. And get this, they often grow right next to each other. How cool is that?
Okay, so we've got these two total opposites, acids and bases. They seem like they're always fighting, but what happens when they actually meet? Well, it's not just about destruction, it's also about creation. There's this amazing fundamental rule in chemistry. When an acid and a base come together, they cancel each other out. But they don't just vanish into thin air. Nope. They transform into two completely new things, a salt and good old water. And that powerful reaction has a name, neutralization. Seriously, it's one of the most important reactions in all of chemistry. You're taking two pretty reactive substances and turning them into something totally stable and neutral. It's incredible. Now, when I say salt, I bet you're thinking of just one thing, right? The stuff you put on your food. But what if I told you that simple table salt is actually one of the most important industrial raw materials on the entire planet?
Yeah, that's right. The same stuff in your kitchen, sodium chloride, is the starting point for a gigantic industrial process. This humble, everyday seasoning gets transformed into chemicals and materials that we rely on every single day.
The whole thing is called the chloroalkali process. Basically, you take salt water, or brine as they call it, and you zap it with electricity. This kicks off a reaction that literally rips the salt water apart into three incredibly useful and totally different products. And the stuff it makes? It's mind-blowing. You get chlorine, which is used to make our tap water safe to drink and for things like PVC pipes. You get hydrogen, which is used for everything from rocket fuel to making fertilizers for our food. And you get sodium hydroxide. That's a strong base, which is absolutely essential for making soap, detergents, paper, you name it. And just think, all of that comes from simple salt and water.
All right, for our last little bit of chemical magic, we're going to uncover one more secret. It's about hidden water. Water that's hiding in plain sight, inside crystals that look completely dry.
I mean, think about a salt crystal. It looks dry, it feels dry, but is it truly dry? The answer is, well, it's not so simple, and it adds a whole other amazing layer to this story.
Okay, look at these gorgeous blue copper sulfate crystals. I mean, they look bone dry, right? But just watch what happens when we heat them up a little bit.
So as they get hot, wait, what's that? You start to see little droplets of water appearing, boiling off. The hidden water is evaporating. And as it goes, look, the beautiful blue color just vanishes, leaving behind a plain white powder. That vibrant color? It was all thanks to the water trapped inside.
This isn't just random water, by the way. It has a name. It's called the water of crystallization. It's a very specific number of water molecules that are chemically locked into the salt's crystal structure. It's part of what gives the crystal its shape and, as we just saw, its color.
And this is way more than just a cool party trick. This exact same principle is how doctors set a broken bone. You know, plaster of Paris? That's just a special kind of salt that's thirsty for its water of crystallization. When the doctor mixes it with water, the powder greedily soaks it up, recrystallizes, and hardens into that solid protective cast. Amazing, right?
So there you have it, from the sour taste of a lemon to the table salt that powers massive industries, all the way to the plaster cast that helps a broken bone heal. This hidden world of chemistry is literally everywhere. So now that you know a little bit of the code, the question is, what hidden chemistry are you going to see in your everyday world?